Hello, this is Brianne Pernick, and here we are, Chapter 0, Lesson 5 for Robert Morris, Math 0900. This is the last chapter that we are covering this week, our first week, and we are going to work on changing a decimal to a percent and vice versa, finding the percent of a given number, finding the missing percent when given two numbers, and using rounding to estimate. Terms that you need to know that we haven't already covered are percent, and let's start talking about what percent is. The word percent comes from the Latin root meaning per 100. Thus, a percent is a fraction that has a denominator of 100. Anytime that you see the word per, that is going to be a hint to you that you are going to be dividing. So just pay attention to that word because that's something that's going to be a clue to you whenever you're doing word problems. So let's take a look at the little example that we have here. We have 67%. Knowing that a percent means out of 100 or per 100, we can write that as a percent by writing 67 over 100. Once you convert that to a fraction, you can also easily convert that to a decimal by doing 67 divided by 100, which is 0.67. When you are given a decimal, converting to a percent simply requires that you move the decimal point 2 places to the right. This is because mathematically you would be multiplying by 100. So it would be a waste of your time to set up a multiplication problem every single time. So what I want you to do there is just simply move that decimal point 2 places to the right, and we're going to have 46%. Move this decimal point 2 places to the right, and we're going to have 30%. We're going to move this decimal point 2 places, and we're going to have 52.3%. And then when we move this one 2 places, we have 0.05%. If you need, let me just point out too, that percents can be greater than 100. So in the event that that happens to you, like this one, you had 52.3%, that one was greater than 100. Okay? No, excuse me. It was not greater than 100. These ones are greater than 100. I apologize. So when we change these ones to a percent, we're going to move over 2 places. So now we have 350%. My apologies. We move this one 2 places. We have 784%. And 2 places there, we have 694.3%. So percentages can be larger than 100 or smaller than 100. And it's useful in different situations depending on what that particular situation is. Perhaps you're looking at how much growth your business has made or how much profit your business has made. Hopefully you would have more than 100% profit. So you're going to look for that to be more than 100%. Okay, moving along. We're going to change a percent to a decimal. Now, we're going to do the exact opposite of what we just did. When we were changing that decimal to a percent, we moved the decimal point 2 places to the right because we were mathematically multiplying by 100. Now what we're going to do to convert a percent to a decimal is move the decimal point 2 places to the left, because mathematically we would be dividing by 100. I want you to think about what we just did here when we talked about taking the percent to a fraction. We wrote it as a number out of 100 and then divided by 100 to get a decimal. That is what we're doing now. We are dividing by 100. So rather than setting up a division problem every single time, I want you to just remember that you can simply move that decimal point 2 places to the left and you will have your decimal. So you will have 0.04. When you move it 2 places to the left here, you will have 1.45. Make that point better. When you move it 2 places to the left here, you have 0.007. Okay. Now we're going to work on our next objective, which is finding the percent of a number. Percent problems are going to have a basic format that we're going to follow. To solve them, you need to remember some basic algebraic concepts. Now let's look at an example. How do we find 60% of 20? First, I want you to remember that in math, the word of means to multiply, and the word is means equals. Okay? So here's what we're really being asked to find. Okay? We're being asked to find what is 60% of 20, right? Do you guys agree that that's what we're being asked to find? Let's look back at the original question. How do we find 60% of 20? I rewrote that as what is 60% of 20? We can further convert that into a mathematical equation by remembering that the word is means equals, the word of means multiply, and every time that we have a percent problem, we have to use it in decimal form. So moving that decimal point 2 places to the left gives us 0.6. So now I have my what is 0.6 of 20. I just have to carry out the multiplication of 0.6 times 20 to find the answer. So go ahead and do that. When you do 0.6 times 20, you should have ended up with 12. So 12 is 60% of 20. Let's do another example. 10% of 36. What is 10% of 36? So 0.10 or 0.1, however you want to think of it, times 36. Go ahead and do that math and you're going to get 3.6. Last problem. What is 11% converted to a decimal gives us 0.11 of translates into multiply 26. 0.11 times 26, and you should get that 2.86 is 11% of 26. Now we want to talk about finding the missing percent when given, two numbers. Now, often you will be given the two numbers and you'll be asked to find the percent. For example, when you receive a score on an assignment, I'm willing to bet that one of the first things that you do is calculate the percent so you know what your grade is. That is exactly what this type of problem is asking you to do. So when it says what percent of 24 is 15, that's like saying, hey, I got a 15 out of 24. What's my grade? So you're going to set up a division problem of 15 out of 24. We're going to divide 15 by 24, and we get 0.625. We learned that we move that decimal point 2 places to the right, and we get 62.5%. So if this was a test, you would have gotten a 62.5 on that test. If you were talking about what's your percentage of basketball shots made, you made 62% of your shots. Okay, one more problem. 24 is what percent of 96? So we do the same thing. Think about it like a test. I got a 24 out of 96. So we're going to set up that division problem. 24 divided by 96, and we get 0.25. Move that decimal point 2 places to the right, and we find out that we earned a 25%. Not too good. Maybe we should think about that as if it were basketball. A little bit happier there. Okay, and our last objective for today is using the rules of rounding to estimate. So for this section, we are going to use the rules of rounding and estimation. So we're just going to quickly look below for a review. When you are rounding a number, if the first digit to the right of the round off place is less than 5, we make no change. So 0, 1, 2, 3, 4, you do nothing. If it's 5 or more, we increase the digit in that round off place by 1. And then estimation by rounding. You're going to round each number so that there is only one non-zero digit. That's how estimation is different. When you're told to estimate, you want to have one non-zero digit and every other number should be a 0. Okay? And then you're going to perform the calculation with your new rounded number. Okay? We use estimation when we do not need an exact number. Estimation allows us to work with simpler numbers that are quicker to work with and easier to manipulate. Of course, our answer will just be an approximation and it won't be exact. It's going to give you a good idea of what the real solution would be. Don't use estimation if you need an exact answer, but you can use it if an approximation is acceptable. So if we're going to use estimation by rounding to find the product, what I would suggest that you do when we're estimating is say, well, 685 is really close to 700, and 4,123 is really close to 4,000. So when I multiply 700 times 4,000, we get 2,800,000. And that is going to be our estimation. Okay? Guys, please let me know if you have any questions about anything. These skills that we covered in this section are very important. Let me know if you have any questions or concerns. I'm here for you. Thanks.